Welcome to the deep dive. This is where we dig into those dense technical sources and pull out the practical skills you need right now.
Exactly. If you're aiming for that certification or just want to be a more effective sysadmin, well, you're in the right place. Today, we're tackling a really fundamental task, something you'll definitely encounter: cleaning up after a failed application deployment. We're turning a mess into a properly integrated system component. That's right. It's all about application directory cleanup and restructuring, taking something broken and making it right, FHS compliant, and, ready to go. So picture this. You've got application files, maybe a binary, a config, a re-ADM, but they're mixed up with junk, core dumps, debug logs, that kind of thing. And the worst part, it's all sitting in vartemp fail deploy.
Vartemp, that immediately rings alarm bells, doesn't it?
It absolutely should. Vartemp is for temporary files. Okay, yeah, sometimes things there survive a reboot, unlike TSAMP, but it's fundamentally not the place for a permanent production application.
It's like trying to set up your permanent office in a hotel lobby. Just no. So where should this application live?
Well, for optional third-party software, basically, anything you installed that didn't come with the base operating system, the standard, the file system hierarchy standard, or FHS, points us to opt.
Right, opt. Keeps things clean, separate from the core system stuff in bin or bin. Makes sense.
Precisely. It helps with organization, upgrades, and eventually removal if needed.
Yeah.
Much cleaner.
Okay, so step one is building its new home in opt. We're calling the application web app. But we can't just dump everything in opt to web app, right? We need structure.
Discipline is key here. You need subdirectories.
Yeah.
Typically bin for the executables, etc. for configuration files, and docs for documentation like that, re-NDME.
And we can create all of that at once, which is neat, using mkdir but with a specific flag.
Yep, the PAM-P flag for parents.
Ah, right. So the command would be something like mkdir dapi opt-web-app-in, opt-web-app-peek, opt-web-app-docs.
Exactly that. DAC2 tells mtdir to create any necessary parent directories along the way. So opt-web-app gets made if it doesn't exist, then bin, etc., and docs inside it. Super efficient. One command.
Okay, structure created. Now we migrate the actual application files from that temporary mess in vart-fail deploy.
And this needs care. We only want the good stuff, the binary, the config, the re-ADME. Leave the junk behind.
So we use the mv command, but specifically file by file. Why not just move the whole fail deploy directory over to opt-web-app and then clean it up? Wouldn't that be maybe simpler?
That's a common thought. But it's better practice to be surgical before moving. If you move the whole directory, you're polluting your nice, clean opt structure with those core dumps and logs right from the start.
Okay. Keep the destination pristine. Makes sense. Exactly. So 3 distinct moves: mv-app.bin opt-web-app. Got it. Then mvconfig.xml opt-web-app-docsec.
All right, the important files are safe in their new home. Now we deal with the original mess. Yes. Time to obliterate the source. Vart fail deploy and all its remaining contents, the junk files have to go. And this is where we bring out the big gun, rm-rf, the infamous rm-rf, Vart fail deploy. We need to pause here, though.
Definitely. rm-rf is powerful. Extremely powerful. Mistakes can be catastrophic. What's the safety protocol here?
Know exactly what directory you're targeting. Yeah. Using the full absolute path like we did Vart fail deploy is much safer than using relative paths or wildcards, especially Vart.
Right, because rm-rf in the wrong place. That's a very bad day.
A very bad day indeed. But here, we've already moved the important files out. We know this directory is now disposable junk, so using the absolute path makes rm-rf the appropriate, efficient tool for the job. Just double-check that path before hitting enter. Always.
Okay. Files moved, old directory nuked, the application is relocated. Now we need to tweak its configuration, right? It was pointing to an old database.
Correct. The config file, opt-web-app-config.xml, currently points to db.old.internal. We need to change that to the production database, db.prod.internal.
Time for a text editor. Vim is the classic choice for sysadmins.
Yep. And inside Vim, we want a fast, reliable way to swap out that host name everywhere it appears in the file. The global search and replace command comes to mind. Something like %db.old.internal, db.prod.internal, that's the one, the colon to enter command mode, percents for substitute across the whole file, %, the old string, the new string, and crucially, the G at the end.
The global flag. What happens if you forget the G?
Bad news, potentially. Without G, it only replaces the first instance on each line. If db.old.internal appeared twice on one line, the second one wouldn't get changed. Could lead to very confusing errors later. Always use the G for safety in full file replacements. Good tip. And then .wq to write and quit Vim.
wq.jobdone on the config file.
But just changing the name of the file isn't enough, is it? The server itself needs to know how to find dd.prod@internal.
Right. The operating system needs to resolve that host name to an IP address. We're told the IP is 10.0.5.1/0. We need to make that mapping.
And for simple, local name resolution, without involving DNS servers, the go-to file is echosts. The classic echosts. We just need to add a line. 10.5.1 db on the prod.internal. The source suggests using echo and redirection. Echo 10.0.5.100 db.prod.internal echosts. Quick and scriptable. But echosts needs root privileges to modify. Doesn't the redirection sometimes fail if you're not already root?
It often does, yeah. If you run that echo command as a regular user, the shell tries to open echoes for appending before it even considers sudo if you piped or something. The redirection part needs the permissions up front.
So what's a safer way for manual edits, maybe?
Well, you could use sudo vim echosts and add the line manually. Or a slightly more advanced trick involves T. You could do echo 10.5.100 db.prod.internal sudo t echosts.
TISDP appends. And piping to sudo t lets you elevate privileges for the right operation itself. Clever.
It is pretty neat. But for a quick one-off as root or in a root script, the echo works fine.
Okay. Files moved, config updated, network name resolved. Now, how do we make this application easily runnable from anywhere on the system without having to type opt webets bnap.bin all the time?
This is where linking comes in. Using the ln command, it lets us create pointers or aliases to files without actually moving the original file from its proper home in opt.
And there are two kinds of links we need to use here, right? Soft and hard.
That's right. Two different tools for two different jobs. We'll use a symbolic link or soft link for the executable, and a hard link for the configuration file.
Let's start with the symbolic link. That's LNN-S. How does that work? I think of it like a desktop shortcut.
That's a great analogy. A symbolic link created with ln-s is essentially just a small file that contains the path to the original file, like a signpost saying the real file is over there.
So we point from somewhere in the system's execution path to our actual binary. Where should we put this link?
The standard place for locally installed executables, things not part of the main OS distribution, is a localbin. That directory is usually in everyone's path.
Okay, so the command is ln-s-opt-webin.bin usr loca bin web app. We link the target, the real file, to the link name, the shortcut.
Precisely. Now, anyone can just type web app in their terminal, and the system will follow the link in sgred localbin to execute the actual file in opt-webappin.
Cool. So that's the soft link, a path pointer. Now the hard link, this one's a bit trickier to grasp conceptually. We use just ln, no SES, what's actually happening under the hood. Talk about inodes.
Right, this is fundamental. Every file and directory on a Linux file system has an inode. Think of the inode as the file's real identity card. It stores metadata like permissions, owner, timestamps, and crucially, where the actual data blocks are located on the disk. The file name you see in a directory, that's just a label pointing to the inode number.
Okay, so the file name is just a reference to the inode.
Exactly. Now, when you create a hard link using ln target link name, you're not creating a pointer file. You are creating a second directory entry, a second file name, that points directly to the very same inode as the original file.
Whoa, so it's not a shortcut. It's like giving the file a second, equally valid name in a different location.
That's a perfect way to put it. Two names, one inode, one set of data blocks on the disk. They are indistinguishable from the kernel's perspective, apart from the name itself. If you edit the file via one name, the changes are instantly reflected when you access it via the other name because they're the same file data.
Okay, that's clicking. And we're using this for the configuration file.
Yes. We link optwebappexconfig.xml to etceterawebappy.com opser. The command is just AAOSAAN, optwebappexconfig.xml, etceterawebapp.conf.
And putting the link in etc. makes it look like a standard system configuration file, easily discoverable.
Correct. Standard location for system-wide config.
Now, here's the really interesting part about hard links. What happens if I delete one of them? Say I delete the original optwebappexconfig.xml. Does the file disappear? Does etceterawebapp.conf break?
No, and that's the beauty and robustness of hard links. The kernel keeps track of how many directory entries, how many hard links point to a specific inode. It's called the link count or reference count.
Ah, the link count.
When you create a file, the count starts at 1. When you create a hard link, the count goes up to 2. When you delete a hard link using ARM, you're just removing one of the names pointing to the inode, and the link count decreases by 1.
So if the count was 2 and I ARM one link,
the count drops to 1. The other link name still points to the inode, and the file data remains completely intact and accessible via that remaining link. The actual data blocks on the disk are only marked as free, and the inode released when the link count drops all the way to 0, meaning the last hard link pointing to it has been removed.
That's a fantastic built-in safety mechanism. Deleting one hard link doesn't kill the file if another exists.
Exactly. Very resilient.
Okay, wow. We've moved the app, configured it, networked it, and linked it system-wide. Seems like we're done, but not quite. Verification is crucial, right? Especially for certification.
Absolutely critical. Never assume your commands worked perfectly. You need to prove it. Verify the structure, the links, the config change, the network setting.
All right, let's verify the links first. The symbolic link in uslocalban should be easy. How do we check that? Use LSL. So ls-ss uslocalban web app. You're looking for two things. The very first character on the line should be an L for link, and the output will show an arrow map pointing to the original path. Opt, web app, bnap.bin. Okay, L at the start and the arrow bit. Got it. Now, how do we verify the hard link? We need to prove they share the same inode.
This requires the I option for else. It shows the inode number as the first field in the output.
LSI. So we run it on both files.
Yes. Run else si octawebapet config.xml and then run ls *i etc sip.conf. Look at the number printed at the very beginning of each line. Those two numbers, the inode numbers, must be identical.
Identical. Okay. If they match, we know it's a proper hard link sharing the same file data. If they don't match, something went wrong. Maybe I accidentally used on S or made a copy instead.
Precisely. That LSI comparison is the definitive hard link check.
Good stuff. Next, let's check the content. We edited the config file with Vim to change the database name. How can we quickly confirm that change took effect? Maybe through the hard link.
A quick grep is perfect here. Grep db.prod@setwebapp.com. If that command spits out the line containing db.prod.internal, you know your Vim substitution worked and is accessible via the link in, etc.
Simple enough. Grep for the win. Finally, the network piece. We added that line to echoes. How do we test if the system can actually resolve db.prod.internal now?
The standard diagnostic tool here is ping.
Okay, so just ping db.prod.internal.
Almost. Add -2e1 to tell ping to send only one packet and then stop. So the command is ping-c1 db.prod.internal.
Right, -c1. What are we looking for in the output?
You want to see it resolve the name to the correct IP address, 10.0.5.1 of our row, usually shown in parentheses on the first line of output, and then confirmation that a packet was sent and may be received, though receiving isn't strictly necessary just to prove name resolution worked. If it resolves the name instead of saying unknown host, the echoes entry is working.
Excellent. That covers all the verification steps. Structure, links, content, network.
And that really brings us full circle. We started with a mess in VertRamp. Now we have a properly structured application in opt, configured correctly, integrated with the network via echoes, and accessible system-wide thanks to understanding both symbolic and hard links.
It really highlights that journey from just knowing commands to understanding why certain standards like the FHS exist, why opt is used, and the deep difference between LNS and LN because of how anodes work. That's the real administrative insight.
Absolutely. But, thinking ahead, there's one more piece to consider. We've deployed it successfully. What about undeploying it later? Responsible administration includes clean removal.
Right. We'd arm in the links, use our local bin web app and etcetera.com, and then rm-rf opt web app. Seems straightforward.
Those parts are. But what about the change we made to echoes? We appended a line. Just deleting the whole file is obviously wrong. Manually editing it to find and remove just that one line can be error-prone, especially in scripts.
Good point. How do you surgically remove just that one line we added programmatically?
That's where a tool like Sege said, the stream editor, comes in handy. You could use a command like setidb.prod_internal. The I means edit in place, db.prod.internal finds the line containing that string and details S to delete that line.
Wow. Desetting pattern file. That's powerful for targeted cleanup.
It is. And mastering that kind of precise cleanup, leaving the system exactly as it was before your application was installed, that's a hallmark of truly professional system administration. Something to maybe explore before our next deep dive.